Alright, so we stopped here in the previous session, and yeah, what I've said is basically that board would render, and if we basically go to that function um, that that belongs to the board class, this one actually, what happens there is that we have basically the camera manager, where we have here two camera managers, one the role and one the semantic. They are taking the display, which is our display, and basically rendering two scenes, right? So basically they are rendering the raw image and the semantic. Now what we do here, regardless what you see there, this is not important, but what we do here now, we call another render function which belongs to the hot class. Now inside this function is where we will do our work. Actually everything else, it's not really important. Of course you can have a look at it later, but basically our work would be inside that HUD, and this HUD basically render takes the semantic image and the raw image. Okay, so which is basically this one here. So just to have a look basically at this line detection PY, which is simpler now than the one you have seen before. It is now just the start. We will see how we can uh, achieve the line detection and the semantic segmentation and so on. Okay, so it's basically our car driving, and if I now it's a bit faster, so I can zoom out. We have one car, which is our car. It is driving now inside. It is inside this tunnel. So should either get out from here or from there. I think it's the other one, because I see these two buildings. Yeah. So just basically what I've talked about, that we have here, this is a server, and our car is moving inside that board, and now it's stopped at red traffic light. Anyway, so what I would like to do actually is to change this environment, because we want to have more like the one that has highway. Most of the map is highway, and if you remember, I've created this control simple which would only replace this map with the map of the highway, this one. Let me zoom out right away. I think this map, the car usually starts somewhere there. It's a nice view. So basically it starts somewhere there and it will drive. And it is a highway, so the car would basically drive along this highway. Yeah, see the car is coming. Okay, so yeah, so as I said, we have this render which takes the image. Here actually is a semantic image. Let me call it the semantic, just better. And this is the raw image. The raw image. Let me put that down here. Okay, so now we are doing very simple task. We have an OpenCV, so it's basically the OpenCV, okay, library, and we are calling the first function that is important for us, which is the image show. If you then also image processing with MATLAB, there's also image show there. This is quite the same. We take the image and render it in the window that we have seen. Of course, these images are rendered every tick of the game, so it's not an image, basically it's a video or it's a scene that will be rendered over time. Now here basically if I click escape, then it will destroy all, which means it will close the game. This is what you see there. Okay, so this is the function. The first part is the name of the window and the second part is the image. For example, I want to also now render the semantic image. And here I would call it semantic. Save. Now see two windows. One is with the raw image and or raw scene, and one is with the semantic segmentation. Okay, we got an error. That is a strange error. Because I didn't change. Here. Because we send back also the raw image. Did I close the server? No, the server is running. Okay, still throwing an error. Again here, okay, sorry. I should have replaced it everywhere. And actually, yeah, it's the same. Okay, so now we have two windows. We have the raw image, and here's the semantic segmentation. Now, if you look at the semantic segmentation, as I said before, we have different classes. We have the load here, we have the load marks or markers, and we have trees and basically everything else. We have, of course, here water, and we would have, if we have vehicles, we would have also different colors and pedestrian colors and so on. Now we know that there is specific color for the color that is basically coming from this camera sensor for the road markers, which is the lanes in this case. And this basically the color that we would use to do the lane detection or to read only the lanes here pixels. You can see it's very good semantic segmentation, despite we have here shadows and we have sun, for example. Illumination is doing well, is not affected at all by the environment. As I said, this is not deep learning. These are called deep learning based semantic segmentation. It's more like built-in semantic segmentation within the game engine because they know this is a road just with different colors and so on. Okay, and this, for example, now the car is on highway, and you can see that the speed here is quite it's quite fast, I would say. And for your assignment to build basically the controller, we don't need to have it that fast because actually it won't be easy. And what is happening here, as I said, for Carla, is that they have the markers or the waypoints that we have seen in the previous session, and these waypoints are on that highway, and the car is only following these waypoints. Okay, so anyway, so we have OpenCV. So OpenCV is basically, as I said, an image processing tool or package, and you can use this to do different image processing methods or tasks or filtering and so on. For example, let's go to OpenCV. No, I don't want installation. I want to check something like edge detection. So, or can edge detection. So, if basically edge detection is, if you are not familiar with that, what is an edge first in an image? So, edge in image is basically an edge pixel, for example, is a pixel where we see or where we observe or where it exists a sharp change in the intensity values. What the meaning of sharp change and what is intensity value? Intensity value is basically the value of the pixel between, which is lies between 0 and 255. So this is basically 0 to 255, the value which is called the gray, let's say gray scale. Now, if I have a colored image, I would have 3 channels, one for red, one for green, and one for blue. And these 3 channels, basically, in each channel, I have pixels values between 0 to 205. Now, just let me use here Carla for some explanations. And OpenCV is also built in with Carla. Anyway, already installed. So just ignore all that code now. And if we have import, yeah, before OpenCV, let's numpy. So an image basically is an array. This array could be 2-dimensional or 3-dimensional. 2 dimensions is for gray image because we have only one channel, and this is the gray channel. If you have 3 channels or more, then it's basically colored image. And these 3 channels, they depend on the color map, but the standard color map, which is the RGB, which is red, green, blue, has basically 3 channels. One for R, one for green, one for blue. And if I have a colored image, it would have, for example, let's say the dimension of 300 rows. So the first dimension is for the rows of the image. And we have 600 columns, this XY, also quick column, and 3 channels. Okay, so whatever the values basically this matrix, or inside this matrix actually is our image. And each pixel has an intensity value between 0 to 255. Okay, so this could be, as I said, green, blue, and red. And then the color basically is a combination between green, blue, and red. Yeah, so now an edge is, so image, you can consider it also like a signal, but two-dimensional signal. And if I take here, let's say if I take one row in this image, okay? So I slice one row in this matrix, two-dimensional matrix, because this is gray. And I take one row. Now the intensity values, let's take this row. Intensity values here are quite static. Not static, but basically they change a bit, but the color is not changing that much, right? This means that the intensity value is quite stable, not changing that much. Now when it reaches here, it's entering another object, which is here messy, like basically, which means that there is a change in the color. There is a sharp change in the color. And this sharp change in the color is an edge, right? So the edge basically represent sharp changes in the colors, and mainly they represent the boundaries of objects within the image. Okay, so this is what is the edge, and for edge detection there are different techniques. There are simple techniques like which you can consider basically they are filters and edges within images. If you are familiar with signal processing, edges within images are high frequency, yeah, because they have this sharp, so they represent higher frequencies. Okay, so if I, for example, if I want, for example, to detect edges, then I would use high pass filter, for example, and the high pass filter is represented by some simple basically operations like convolution as well, and they are called, there are some filtered kernels there, like Subol, for example, that is used for edge detection. And gradient itself of the image is also an edge detection. If you have a signal and you estimate the first derivative of that signal, you usually get basically the peaks values, right? Or you get peaks where there is a sharp change in the signal. So you can apply the same on images, and if you apply the first derivative actually, which is the same as Subol, which is the same as high pass filter actually, then you would get the edges as we see here. Now this is not an image processing class or course, so I will not go more into details, and you don't need really to care about that or about the theory now of edge detection. But what you need to care now about is that there is functions within OpenCV that you can use for edge detection. Now, there's very famous technique or methods called CANI, edge detection, which is a combination of different techniques for robust, basically, edge detection. So this is what I would do here. I would take that, and then I would put it here, okay? And I want to detect the edges of my image. But before doing that, we need, because our image here is colored. And what I want to do, there's another function within OpenCV that we can use, is that I want to convert this image from color to gray, okay? And to do that, instead of just searching, I would, because I have it here, there is a color converter basically function that we can use that would convert our image, colored image. So here I'm working with the colored image, with the raw image, not with the semantic image. So the first step is that I'm converting this colored image, which is actually it is in blue, green, red format to gray. Okay, and then I'm using this gray as an input to the canny edge detection. Now these two are called the lower threshold and the higher threshold of canny edge detection. Yeah, you don't need to worry about now, but basically that they represent strong edges and weak edges basically. Yeah, if this is the page, as I said, of canny edge detection. If you want to know more about it, then you can have a look. Or if you have basically taken the machine vision classes, then you probably, or you should know actually canny edge detection. Now, what I want to do here is to just to see what this represents. I'll take the gray first, gray image. Then here we take, let's call it canny edges. Okay, so now we see basically 4 windows. We have the origin window, and we have the semantic. We have gray, so you see now we don't have color anymore, and we have canny edge detection. Now we see here that this basically the edges. So it is like a binary image. You can consider binary means it's only black and white, so it's not gray. And we can see basically white represents edges in this case. So we can see even the shadow edges here are detected. Now this is canny edge detection, and edge detection is one of the steps that you would need to detect lanes if you are not using semantic segmentation, because semantic segmentation makes things easier. But if you don't have semantic segmentation and you don't have deep learning model, then traditionally actually it was done this way. You detect the edges, then you do what is called line detection, which is using a technology called Hoff transforms. And there you would detect the line, which means you would detect the models of different lines in this scene. And then of course you can take the lines that they have certain orientations that represent the lanes in general that is facing one car. Okay, so this is basically some of the functionalities of OpenCV. Now, what is the next step? So these actually are not steps here, just as a function that we can use later. But the next step is now we have the semantic image or semantic scene, and we need now to segment, or actually what we care now about only is the lane and lane colors, or basically the road markers color. Now with the documentation of Carla, you can see the color value of the road markers, which is just a second. Here I'm just have already implemented code. Okay, so we see it here. Okay, so what we're gonna do now is basically create something called a mask, which here actually it is just representing, it's just segmenting the lanes pixels. And as I said, there is specific color which actually at the specific channel, which is here in our case is the blue channel, sorry, the red channel, because here we slice the not the first, the second channel, because the first 0 and the second channel, which is basically the red, because here we have BGR, as I said, color codes or color map. And the color map that is equal to 234 is the color map of, or the color value, or the pixel value of the lanes. So what I've done here is that this is just give me basically all the pixel values, so it's basically Boolean, which would actually return true or false for all the pixels that they either have the value of 234 or they don't have the value of 334. Then I'm just setting it as a float, and here basically, which means they will be converted from Boolean to float, which mainly will be converted from true false to 1 zeros. Then I'm multiplying it with 255 just to make it as an image again, because I said the scale of image is between 0 to 255. Yeah, and here what you would get is a gray image. Why? Because actually you would get also two-dimensional image. Why? Is because here we sliced one channel, which means we converted this three-dimensional matrix to two-dimensional matrix. Now the issue of image show, as you will see later, check what I want to show now. Let's show the okay. No. Yeah, let's show the mask itself. And if I want to show the mask, I need to convert it again to three-dimensional image, because we cannot show two-dimensional array here because it doesn't represent an image, and OpenCV would not consider it. And here, let's say I'll call it the segmented length. Okay, so this name, if you have different HUDs, you would have different name, but here we don't have, so just keep it as this. Okay, so what this step is doing is just converting the two-dimensional matrix to three-dimensional matrix and to the colored matrix again. This is not a very important step. It will be important for later steps, as we'll see in the next maybe 3 minutes. What we are doing here, I'm just adding a new dimension by using something in Python called, or in NumPy actually, np.newAccess. So here just extending the array from 2D to 3D. Then here I'm just repeating the values in the first channel and copying them to the next two channels. So this is what is happening there. Now here I am showing this mask again. So let's see what we get out. So we have I think it was not saved because I still see the candy. Okay, so it seems there's an error. Yeah. We don't have an image, we have raw image. Okay, now it's not working. Do you know why? Because I took the image instead of the semantic image. And of course, the colors there are not correct. Here I had to take the semantic, sorry. Okay, now it's cool. See, so here basically is our binary image where we see now only the lens. So we don't see anything else. We see the lens, and these lens are, of course, what we need to do uh, to estimate our path, and basically to use this path for mainly the lateral control. Okay, so just if we look at this, what we want to achieve, having this lens actually, if I can get the, of course, the model of this path, which is the polynomial fitting of this point, and the polynomial fitting of this basically curve here, then I can basically get my path. Let's say the my path would be the average polynomial between these two, which is basically the straight line here in between. And if I have that, then I can basically use that as a set for as a reference for our lateral control. Okay, now there is something we can do with OpenCV to make this, let's say, lanes more clearer, is basically by using something called dilation. Now this dilation takes a gray image, so we actually would need that. No, actually we would take it from here. We have CV2 dot dilation, which basically would add some thickness you could consider to the edges. So this is basically our two opposites, I would say. There's erosion, which basically if you have an edges like this, then it will reduce their thickness, as you see there, and here it will increase it with dilation. So we want to take dilation. We have different kernels that can be used and different iterations. This, as I said, not in the scope of this course, but let's first create or take that specific kernel, and then let me take this. Yes, here we call the kernel, and our kernel is named here, and then we need that mask. Then maybe we use it as a mask again. And now let's see what would happen. The car here, as you see, sometimes doesn't spawn correctly, so you have to start again. Yeah, it didn't change much. I don't know if it was saved. Okay, we got an error here. So we have CV2 kernel mask. I think the license should take a gray image. Let me try to check if it's wrong because of the dimension or something else. Okay. Then it takes a binary image then, which makes sense. So okay. Try something. If not, we'll check it later. But basically, if a binary image, as I said, is either 0 or 1, or either true or false. So I will try first to have the true false, and I will call here mask binary. New. Actually, it takes any image, but okay. So I think it is. It also could be the data type, because pixels are considered to have unsigned integer 8 mainly data type. And here, last try. Then I'll need to stop the video, because sometimes if I record longer than 30 minutes, it crashes. No, okay, I'll stop the video, then I'll continue.